Hello friend, oi amigo, oi amiga. Welcome to this lesson of Welsh Inglês Técnico. This is the lesson Common Number Sets or Conjuntos Numéricos. In this lesson, we'll review the names, symbols, and elements of the most common sets of numbers used in our math studies. Como sempre, este é o vídeo onde eu apresento a matéria da lição só em inglês. Existe outra versão desse vídeo onde eu apresento essa matéria também em inglês, mas vou acompanhando passo a passo com explicações, pronúncias e dicas da matéria em português. Let's look at the list of topics for this lesson. In this lesson, we'll look at many sets of numbers. We'll look at the natural numbers, the integer numbers, and subsets of the integers. We'll look at the rational and irrational numbers, real and imaginary numbers, and then finally, the set of complex numbers. Our first set of numbers is the natural numbers. Natural numbers. These are the numbers that we use when we are counting. 1, 2, 3, 4, and so on. We use them when we count. We give this set of numbers the symbol N, capital N, for natural. And you see it there in the little yellow circle. Each of these sets will give it a symbol and place it in the little yellow circle there. Now, some people say that the natural number set begins with 0, not 1. So some people include 0 in the natural numbers, so they start counting with 0, 1, 2, 3, 4. But in the United States, most often, usually, the set that begins with 0 and includes the counting numbers is called the set of whole numbers. Whole, W-H-O-L-E, whole numbers. That set is 0, 1, 2, 3, 4, and so on. Like I said, some people include 0 in the natural numbers, others do not, and call this the whole numbers with the symbol W. The next set that we will look at is the set of integers. The set of integers, and we will also look at some of its subsets. The set of integers is formed by one of the sets we looked at before, the whole numbers, 0, 1, 2, 3, 4, and so on, plus the additive inverse of each of those numbers. What's an additive inverse? Well, another name for additive inverse is opposite. So it's 0, 1, 2, 3, 4 plus the opposite number of each of these. What's the opposite? Well, for example, the opposite of 3 is minus 3. The opposite of 2 is minus 2. The opposite of 1 is minus 1. Remember that each of these pairs adds up to 0. So additive inverses are inverses that add up to 0. So the set of integers has 0, and then the positive 1, 2, 3, 4, and the negative minus 1, minus 2, minus 3, minus 4. So this set, the integers, has its symbol Z, capital Z, that you see there. Now let's look at some of the subsets of the integer set, some subsets. Here we list 5 subsets. First, the set of positive integers. 1, 2, 3, 4, 5. These are greater than 0. Greater than 0. If we add 0, then we have the non-negative integers. Non-negative integers, that means they are not negative. Non-negative integers, 0, 1, 2, 3, 4, and so on. Of course, we have the negative integers. These are the additive inverses of the positives, remember? So the negative integers. Now we have two more subsets that we often mention together. These are the odd and even integers. Odd and even. The odd numbers, -3, -1, 1, 3, 5, 7, 9, 11, and so on. The even numbers, -4, -2, 0, 2, 4, 6, 8, 10, 12, and so on. Next, let's look at two more sets of numbers. These are the rational numbers and irrational numbers. Rational, irrational. The rational numbers are those fractions of integers. Fractions of integers. More formally, the rational numbers are all numbers that can be written as a fraction of two integers, a and b, where b is not 0. One more time. The rational numbers is the set of all numbers that can be written as a fraction of two integers, a and b, where b is not 0. So rational numbers, fractions of integers, and the symbol is Q. The symbol is Q. So if the set of rational numbers is the set of all numbers that can be expressed as a fraction of two integers, the irrational numbers is the set of all numbers that cannot be written as a fraction of two integers. Again, the irrational numbers is the set of all numbers that cannot be written as a fraction of two integers. The symbol for irrationals is the capital letter I. I. Now, you probably remember that some of these irrational numbers are very famous and they're very important. Here I list just 3 of these very famous and important numbers. You see pi, the square root of 3, and the number E, or Euler's number. E-U-L-E-R, Euler in English, Euler's number. This means that none of these numbers can be written as a fraction of two integers. You can get close, but not exactly. Now let's talk about the real numbers. Real. There's nothing more realistic about these numbers. That's just the name. The set of real numbers can be thought of as the set of all numbers that can represent a distance along a continuous number line. Again, any number that can represent a distance along a continuous number line, that's a real number. So a distance of 2, 2.5, 3, 3.5, 3.1, 3.2, 3.25, all of those numbers could be a distance along a number line. They are all real numbers. Another way to think of it is that it is the set that contains the complete set of rational and irrational numbers together. Rational and irrational numbers together. Well, the imaginary number set is the set of all square roots of negative real numbers, or 0. Again, the imaginary number set is the set of all square roots of negative numbers, or 0. To help us think through and use imaginary numbers, we have the definition of the square root of -1. This is called the imaginary unit, and it has the symbol I, lowercase, little I. That's the imaginary unit, and it is equal to the square root of -1, square root of -1. Now, any number in the set of imaginary numbers can be expressed as the product of a real number and I, a real number, and the square root of -1. This is BI that you see there. So any imaginary number can be thought of as BI, where B is a real number and I is the square root of -1. Finally, let's look at the set of complex numbers. This set is defined using the previous two sets, the real numbers and the imaginary numbers. The elements of the complex number set are defined like this. All numbers that can be written as A plus BI, where A and B are real numbers and I is the imaginary unit. Let's do that one more time. The complex number set is the set of all numbers that can be written as A plus BI, where A and B are real numbers and I is the imaginary unit. So then, since every complex number can be written as A plus BI, we can think of the A as being the real part of the number and BI as being the imaginary part of the number. So every complex number has two parts. One is called the real part, A, and one is called the imaginary part, BI. Now, please remember, there is nothing real or imaginary in the usual sense of those words. These are just the names of the sets. So they are both very true, whether we call them real or imaginary. We've arrived at the end of this lesson on common number sets. Let's quickly review what we learned. Well, we began speaking about the natural numbers. Those are the numbers we count with, 1, 2, 3, 4, and so on. We reminded ourselves that in the United States, the whole number set includes 0, 0, 1, 2, 3, 4, whole numbers. Then we talked about the integers. The integers have the whole numbers and their additive inverses, -1, -2, -3, stretching in both directions. Next, we used integers to form a fraction, building the rational numbers, those that can be expressed as A over B. And we said that those that cannot are the irrational numbers. Next, we talked about the real numbers, and we said that those are the numbers that can represent any distance along a continuous number line, right? A distance along a line. And next, we talked about the imaginary numbers using the square roots of -1. Finally, we used both the real numbers and the imaginary numbers together to form the complex numbers. So, what comes next? Well, next, I recommend that you go listen to this same lesson with the explanations in Portuguese. Go listen to the other video, watch it, study it, then come back and watch this one again. I've enjoyed spending this time with you. I hope you have too. And I'll see you in the next lesson. Bye-bye.